I am Akshata Kulkarni from Executive MTech batch, and today I am presenting the title a reinforcement learning strategy for optimizing the utilization of ephemeral cloud resources. And the authors of the articles are here, as mentioned here, and whatever this article has been extracted from the IEEE Cloudcom 2020 conference. So the link is provided here for further reference. And let us learn what does this reinforcement learning strategy and what are these ephemeral cloud resources in the further slides. Basically, these ephemeral cloud resources, what are these ephemeral cloud resources? These are the temporary deployments which contain a self-contained version of your application or any application for that matter, which we are using in the article that matters the most. So coming to the further step of this presentation, usually for any research there is one of the problematic statement for which we need to find a solution, for which we need to find the any other alternative methods. For this presentation, for this article, the problematic statement is cloud data center efficiencies are over provisioned to manage demand peaks and hardware issues, which is subjected to minimal necessary utilization or a lower necessary utilization, which will affect the hardware failures or the hardware burns for that matter. Minimization of the amount of reclaimed resources when avoiding SLA penalties. SLA penalties are nothing but a service level agreement violations which will affect the margin level of any system or any providers. This poor margin, which is providing the poor trade-off between the amount of resources to reclaim and the risk of SLA violations. And this comes here the problem of the this method. So let us find how best we can provide the solution for this problem. Usually these cloud providers aim to offer resources such as virtual machines or containers with the best quality of service possible at the best. So to do so, providing the virtual machines or containers, these data centers are dimensions according to their peak resource usage, with the downside of having a low average resource utilization. The lower resource utilization increases the total cost of ownership, which made reclaiming unused resources. And to achieve that, these cloud providers have to estimate their future utilization according to their availability of guarantees. Okay, these are the some solutions which we have come. One is introduction of virtual machines or introduction of peak resource utilization or something like that with the low resource utilization, and keeping in the mind of service level agreement violations. Coming to the novelty, one way to improve resource utilization and thus reduce the total cost of ownership is to offer the unused resources at a lower price. For example, in a hard disk, the very less portion we use, and the more percentage of the portion is left unused, and it's neither used for a good purpose or it's neither used for a what I can say any other applications, nor it is remain empty. So what the best we can use is the unused resources at a lower price. We have to margin the target. However, this reselling resources needs to meet the expectation of its customers in terms of quality of service. Like the unused resource, whatever we are selling, it should reach the demand of the customers, whoever is purchasing that product. And one more thing is it should reach the customer's expectations in terms of quality, whether the quality is good or it's very poor or something like that. And it also have to keep in mind that the quality of the service or the quality of the resource provided should be tolerable to the workload provided. Then only it's fruitful to resell the unused resource and also to purchase the unused resource. The goal is to maximize the amount of reclaimed resources while avoiding SLA penalties. The challenge is to find the safety margin first thing, and that provides the best trade-off between the amount of resources to reclaim and the risk of SLA violation so as to maximize the amount of reclaimed resources while avoiding SLA penalties. It should be in that matter SLA violations or the service level agreements charge whatever we are offering or whatever we are claiming, it should be less, and the resources should be resold in a good or a fair price. Coming to critiques of this method is our solution reduces significantly the SLA violation penalties on average by 2.7 into and up to 3.4x. So it also improves considerably CP's potential savings by 27.6% on average and up to 43.6%. This 2.7x and 3.4x, which is considerably a potential saving by 27.6% and 43.6%. It is the overall calculations of the presentation or a method whatever we are operated. The strategy, by doing this strategy, it consists of setting a dynamic safety margin on a host level basis for each resource metric. The strategy learns from the prediction errors and improves the size of safety margin accordingly. This is done to reduce the SLA violations penalties. Okay, and this reinforcement learning algorithm, which is responsible for adjusting the safety margins, it does by so continuously observing the resource prediction errors of the forecasting builder. When we keep the system for the operation, these all observations are kept under the conditions of the SLA violations and in terms of the QoS, that is a quality operating services, to act accordingly. Coming to the scope of environment of this project, and before moving to the scope of improvement, we'll check for the schematic diagram of the same. This is the schematic diagram of the presentation. This is a releaser safety margin selector which we have selected, and this is a forecasting builder, and this is the host system. We have to utilize the unused portion of this host system in such a way that without harming the host system. Okay, and here is the QoS controller, that is a quality operating system, which will manage or which will manipulate the quality or which will make the quality in retain in the same state without harming the host system also and without harming the unutilized resources also. Once this process is done, it is sent to the operator, where in the operating system many usual applications, many usual performances will be done by keeping in the mind of the host system and by keeping in the mind of the quality level of the product or unutilized resources. And finally it is sent to the customers, and these customers, whoever will purchase this unutilized resource, they can come back saying this operator is not maintained under a quality check, or it is maintained under a quality check, or whatever queries they have about that system, they can return back to the operating system, and again the operating system is remodularized into the basic things, or it is remanipulated in such a way that customer, whoever is purchasing, can be reached. Customer is satisfied with whatever unutilized resources is providing. So coming to the scope of improvement of this presentation, is the goal is so to maximize the amount of reclaimed resources while avoiding the SLA penalties, this which we have checked in the solution list also, that SLA penalties should be minimized and the reclaimed resources should be provided. Cloud providers have to estimate their future utilization to provide availability guarantees. To overcome these SLA violations and other challenges, implementing Releaser, a reinforcement learning strategy for optimizing the ephemeral resources. Releaser is a short form of this reinforcement learning strategy for optimizing the ephemeral resources utilization in the cloud. This Releaser dynamically tunes the safety margin at the host level for which resource metric the strategy learns from past prediction errors. Here, this releaser should be sustained for any workload, whatever has put on the margin, and also should provide the quality service to the customer. This is all about the releaser. And here are some basic reference links from where I have referred the information about this article.